Let's go over the word mechatronics. Mechatronics comes to respond to the increased demand of engineers with cross-disciplinary knowledge. Companies were in need of engineers, mechanical engineers with knowledge in electrical field, and vice versa, electrical engineers with knowledge of mechanical concepts, and mechatronic degrees or mechatronic classes come to answer to that demand. So explaining or involve students in different disciplines. We can find a lot of different types of mechatronics systems around us. Probably the easiest ones are robotic manipulators, aircraft simulators, adaptive suspensions in cars, landing gears, and micro electromechanical systems, commonly called MEMS. These are sensors that you can find inside, for example, of iPads or phones or cameras to measure gravity, acceleration, and etc. Mechatronics is composed by different fields: the mechanical system field, the electrical system field, the intersection of these two fields, the electromechanical systems, the computer systems field, and then the intersection, the digital circuits, and at last the control systems, which derives the digital control when intersects the computer systems, and actuators and sensors when intersects with the mechanical systems world. We also have these spaces over here where you have actually the intersection of three big groups, and that gives you the name of microcontrol, simulation, system models, and analog circuits. So as you can see, mechatronics is vast, long, and has a lot of knowledge from different fields. As a freshman in your first quarter at DU, you took a class, Intro to Mechanical Systems, where you mainly focus on the mechanical systems area. You cover gears, levers, and basic mechanical systems. Then in your second quarter, you start going to towers, actuators, and sensors, and analog circuits, resistors, diodes, transistors. These are the contents or the concepts covered in Intro to Mechatronic Systems 1. And then for Intro to Mechatronic Systems 2, we are in this digital circuits world. This is where you cover logic gates, CPUs, and things related with computers, with the brain of the computer. Probably one of the easiest examples of a mechatronic system is a car. The suspension, dampers, coil springs, shock absorbers, those are the mechanical components. Then you start putting sensors around: the steering sensor, acceleration sensor, displacement sensor. Those are the analog components that you put around to capture the world, the sensors, the data from the world. And then at last you have the ECU, or the central unit, that gathers all that information and then is going to process that data. Those are the concepts of Intro to Mechatronic Systems 2.